So the final part of this chapter is about working out the equation of a line of best fit. So after you've drawn a line of best fit, a question might then say, right, well, work out the equation of it. That has an application because you can use your equation to work out what points would be outside or inside. You know, if you wanted to work out interpolated or extrapolated results, you could use the formula to do it. So that's the reason for doing that. So for example 1, it's got these 4 coordinates on a straight line, 1, 2, 3, and 4, and they're all on the straight lines exactly. So draw the line and then determine its equation. So we've got the line here, we've drawn that with our 4 different coordinates, and it's asking us to determine its equation. So any straight line follows the format of y equals mx plus c. Now the m is the gradient. I'm not sure exactly why m is the gradient. That might be something quite interesting to find out why it's m and not g. So the gradient represents how steep the line is. It means when you go across by 1, how many units up do you go? So this is going to have a gradient of a half, because when you go across by 1, you go up by half. When you go across here by 1, you go up by half. It's got the same gradient all the way through. So in this example, the gradient is a half. And that can be worked out using the formula, the rise divided by the run. Now the rise is, if I chose 2 coordinates, let's say that one and that one, the rise is how much of a difference there is in the height. So the rise goes from 6 to 9, so the rise would be 3. And the run represents how far you would run across. So it's going to be 1, 2, 3, 4, 5, and 6. So you go across, or you run by 6. And then doing 3 divided by 6, you would also find that the gradient is a half. Now this C part, the bit that goes at the end, is another number that we need to find. The y and the x always have to stay as y and x. You never change them when you're trying to find the equation of a line, but you have to change the m and the c into numbers. So the c represents the number that it goes through the y-axis. It's called the y-intercept. And this value here is 6. So overall, you're going to end up with this equation. So that you see that the y and the x stay as y and x, but you've changed the m into a half and you've changed the c into 6. And this is the equation. So, I mean, how would that be useful if I said, right, well, find the value of y when x equals 10. Well, 10 is off the grid, so you'd have to use this equation then to work out what it would be. So you'd put 10 into that and then work out what y is. So then y would equal half of, in brackets, 10 plus 6. So then that would be 5 plus 6, which is 11. And again, 11 is off the grid, it'd be up here somewhere. So that's why that equation is useful. Okay, let's have a quick look at example 2, and then you can crack on with some questions. So this says the following graph shows a scatter plot and the line of best fit. So the scatter plot is all the different crosses, and the line of best fit is the straight line through. So the question is asking for us to determine its equation. So we'd have to do the rise divided by the run to find the gradient, and then we'd have to find the y-intercept using the graph here, which it looks like it's about 5. So I'm going to have to use a bit of space down here. For part A, we need to, we first of all, it's going to be y equals mx plus c. It's a straight line. Y equals mx plus c. So what is the m going to be? M is the rise divided by the run. And so we'd have to choose 2 coordinates. Now I'm going to choose 2 coordinates that lie on the line exactly and that are far apart from each other. So I'm not going to use that one. I'm going to use this one here. The reason you choose coordinates that are far apart is because then it's more accurate. Because if I chose this one and then this one, then the rise and the run will be difficult to work out exactly. So I have to make my coordinates far apart from each other. So if I to draw as a rough triangle here, then I can say that the rise goes from this point to this point, which is 1, 2, 3, 4, 5. But look, that is not 5. If I have a look at these values here, it's actually not 5 at all. It's 10, because each square represents 2, so it's actually got a rise of 10. This is something to watch out for. So it's 10 up, and what about across? These are single units, and it goes from 2 up to 22, so it must have a run of 20. Therefore, the gradient is a half, 0.5. I could write that as 1 over 2. I'm just going to write it 0.5, just for the hell of it. Right, what about C? The C is the part where it goes through the y-axis here, which is 5. So overall, the equation of the line of best fit would be a half x plus 5. I'll do that in a different colour. Let's choose this one. So y equals a half x plus 5. And it says here now to use the equation to determine y when x is 4. So for part B, when x is 4, y would equal a half of 4 plus 5, which would equal 7. And for part C, let's do that in orange, yeah. For part C, use the equation to estimate x when y is 18. So now I have to say then 18 equals a half of x plus 5, and then rearrange this to find x. So I should do this underneath actually. I shouldn't do arrows like that. That's messy. I'm going to take away the. I'm going to put the equals in the same place and take away 5 from the 18 to give 13 equals a half of x, and then double both sides to get 26 equals x. And that looks about right. I think I could look back at the graph to see if that makes sense. So when x is 26, y should be 18. So when x is 26, which is about here, that should be 18. Yeah, it's about 18, yeah. That looks about right. Cool. That's it.